Proving trig identities is an extension on simplifying trig expressions. So if you've not yet watched that video, make sure to check that out. But what we're going to do here is we're going to take some identities. So these are things that are true. And we're going to show the step-by-step process, the logical step-by-step process that proves that those identities are true. So just a heads up, if you look at number 1 here, we're going to verify that this identity is true, that cosine times secant minus cosine is equal to sine squared. Now, if this looks like an equation, right? It looks like some algebraic equation that I could maybe try to solve. But if you think about the way that you solve equations, that's not the way we're going to prove trig identities, okay? So we're not going to, like, whatever we do to one side do to the other process that we do with solving equations. What we are going to do is we are going to start with one side, okay? So we're going to pick the side that looks more complicated, okay? And it's okay if you pick either side. The idea is you're going to end up at the other side, okay? So if you start with the more complicated side, you can end up with the more simplified side. However, maybe you're like, well, both sides look complicated, so I'm just going to start with this side and see what I can do. And that's great. And we'll look at an example here where we may do that and then be like, well, maybe we should have started with the other side. Okay. So start with one side. What we're going to do is kind of just use our algebra skills, working with fractions, things like that. We're going to use some identities like we did in simplifying trig expressions. And then if you are stuck, my number one tip is to convert things to sine and cosine. That will help you get unstuck. So I'm just going to jump into this first example. I want to prove that this is true. The more complicated side is the left side. There's more going on there. So what I'm going to do is I'm just going to say left-hand side equals. And I'm going to do what I would do with the left-hand side, right? So the left-hand side, what I would suggest doing here is distributing your cosine x. So left-hand side equals cosine x times secant x minus cosine squared x. Right? If I distribute that cosine, that's what I'm going to get. Notice I haven't done anything at all to the right side. Okay? I'm not going to use that at all. I'm going to get there in the end. I'm just looking at the left side. I'm doing some stuff to the left side. The next thing I would do is change secant. I got a little bit ahead of myself. Change secant to 1 over cosine, right? Secant is the reciprocal of cosine, so I'm going to change that to 1 over cosine. And then if I were to multiply cosine by 1 over cosine, those cosines are going to cancel, and I'm just going to get 1. So this is going to equal 1 minus cosine squared x. 1 minus cosine squared x. That is a Pythagorean identity. So if we look at Pythagorean identities, it's a modification of this cosine squared plus sine squared equals 1. 1 minus cosine squared is equal to sine squared. So I'm going to then go ahead and say that 1 minus cosine squared is sine squared, which is the right-hand side. And so what I have shown is that this identity is true, and I've done so by looking at very logical steps from how to get to that left side to that right side. Okay? So we're done. That is our proof. Looking at number 2. 2 times tangent x secant x equals 1 over 1 minus sine x minus 1 over 1 plus sine x. Okay. You might say, well, hey, both sides look kind of complicated. Which one do I start with? And the answer is that, again, start with either one. Okay. Let's say we start with the left side, because you're like, well, I'm not dealing with sine or cosine, so I know I can do some stuff with that. So let me do that. Let's say we start with the left side. We start with the left side. The first thing that I would do is change tangent to sine over cosine, and change secant to 1 over cosine. Well, now I see that I've got some multiplication going on here. I could go ahead and multiply, so I'm going to get 2 sine x in my numerator. My denominator is going to be cosine squared x. And then I'm not really sure what to do from there. And that's okay. All right, that's okay. That's totally fine. Don't erase what you have written. Okay, don't be like, oh well, I guess I should start from the right side. Let me just erase all this and start over. No, you don't want to start over, because what you're trying to figure out is what are the puzzle pieces in between the left and right side to get those things to be equal. And I've done a couple of steps from the left side, so I don't want to like erase that. But if I start from the right side, all I have to get to now is this place where I got stuck, because I have the logical steps that connect back to the left side. Okay, so it's totally fine if you start with one side and you get stuck. Then start with the other side. So I'm just going to stop. I'm going to use a different color of ink so I don't get this confused. But I'm going to say, well, let me start from the right side and let me just try to get back to where I got stuck. So if I was starting with the left side, the right side, we're subtracting fractions here. We're subtracting fractions, so I need to get a common denominator. And to do that, I'm just going to have to multiply each denominator by the other one. Now, because my numerators are 1, that means my numerators are going to become the other denominator when I do this. So my fraction on the left, I'm going to multiply by 1 plus sine x, which means my numerator is going to be 1 plus sine x. My denominator is going to be 1 minus sine x times 1 plus sine x. And then minus, and then on the right side, I'm going to be multiplying by 1 minus sine x. So my numerator is 1 minus sine x, and my denominator 1 minus sine x times 1 plus sine x. Okay, so we have a common denominator now, so we can go ahead and combine these. So our numerator is going to be 1 plus sine x. I am subtracting here, so I need to make sure that I get this negative to both of these. So it's going to be minus 1, but then that's going to be plus sine x. And then on the bottom, I'm going to have 1 minus sine x times 1 plus sine x. That's my denominator. I'm going to go ahead and simplify my numerator. So the 1 and minus 1 will cancel. I have sine x plus sine x, which is 2 sine x. Well, hey, that's awesome, because that's what my numerator was here. On the bottom, so now I'm just focused on, okay, I've got to get my bottom to get to cosine squared, right? So I haven't been multiplying this out yet, but I'm going to go ahead and do that now. I'm going to go ahead and multiply out 1 minus sine x times 1 plus sine x. So if we distribute here, we're going to get 1 plus sine x minus sine x minus sine squared x. And the plus sine x and the minus sine x would cancel, which means I have 2 sine x over 1 minus sine squared x. 1 minus sine squared, hey, that jumps out to me. I replaced 1 minus cosine squared with sine squared, so 1 minus sine squared, that's cosine squared. So 2 sine x over cosine squared x, which is where I got stuck. So I'm just going to put equals, I'm going to draw an arrow, and I have the logical steps connecting the left and right side. That's the goal. That's what we want to do. Always looking to get those left and right sides connected. Using identities, changing things to sines and cosine, using algebra skills like adding and multiplying fractions, things like that. Those are going to be the skills that you need to prove trig identities.